Hello, Riles. For factoring, I have an activity that I want to run through. It should help us sort of see how this X or cross or lollipop method works. And then we'll take a run through one more factoring problem. So the activity that I want you to try out with me is answering the question, for what integer values of k can the following expressions be factored? So I've got 2x squared plus kx plus 3. So what this will do, I think, is help us understand the options that we have for our coefficients when we're factoring here. For example, this is not a factoring question. I'm not asked to factor this. But maybe I could imagine that this could be a 2x multiplied by a 1x to give me 2x squared. That's one possibility. And another possibility would be I could have a positive 3 multiplied by a positive 1 right there. And that would give me my exterior term of 2x squared and my constant term of plus 3. It would give me an interior term of 2x plus 3x of plus 5x. And there's the plus 3. So it looks like positive 5 is one option. Positive 3 multiplied by positive 1 was one way that I could think of multiplying two numbers to get together to get positive 3. But I can think of another way of doing that. If I ignore my signs and I just want my absolute value to be 3, I realize that if my product was the multiplication of two negatives, my product would still be positive. And in this case, maybe you'll just notice that my inside term will be the opposite of that. I'll get a 2x squared minus 2x minus 3x, that's minus 5x or negative 5x, and plus a 3. So it looks like k could be positive 5 or negative 5, and I'd still be able to factor that. Sometimes people will say, but k is positive, and that's not true. K has a positive coefficient in front of it. K itself may be positive or negative. Those would both be integer values. The reason, by the way, we need to say integer values here is that if I make k 1/2, technically I could remove a factor of 1/2 and then still factor this expression. So make sure we're clear on only looking for integer values. Well, notice in both of these cases, I had 2 times 1 giving me 2 and 3 times 1 giving me 3. But what I haven't considered is the order or the way that they're grouped. So what if I put 2x and an x in separate brackets, but I put the 1 in the bracket with the 2x and I put the 3 in the bracket with the x? To make sure we understand, I haven't really considered this option yet. I could still get 2x squared plus 3, whether these were both positive, or let's get it out of the way now, they're both negative. That would still give me that interior, or sorry, those two exterior terms, the x squared term and the constant term. So what I want to do is consider what interior term would give me this factorization. I'd get a 2x squared. This would be what, plus 6x plus 1x, so plus 7x plus 3. And I'm going to predict that this is just going to be the opposite of that term right there. I'll have 2x squared minus 3x minus 1x. That's minus 6x minus 1x minus 7x plus 3. So there are my values. And the activity here, the purpose of the activity isn't to try to memorize or figure out a shortcut for figuring out what k values will make this factorable, but to sort of illustrate the process that we're going through here of trying, when we use our x method, of sorting and trying all of the factors of these numbers, but also of making our numbers smaller before they get larger. Instead of worrying about factors of 6 and coming up with all of the different numbers that factors of 6 could add or subtract to. Okay. Let's try this one here. I think we're going to have more options here, so maybe I'll just try to work horizontally. I could have 4x multiplied by x. That would give me a 4x squared. And how about we have a 5 and a 1? Oh, the reason why this one won't be as long is because I think there may be fewer options for the signs here. I could have positive 5 and negative 1. That would do it, right? I'd get 4x squared and minus 5. And then my interior term would be, let's see, 4x squared minus 4x plus 5x would be plus 1x minus 5. Let's try that one with the signs changed. Sorry, there shouldn't really be an equal sign out there. Let's put minus 5 there and plus 1 there. That would still give me a product of negative 5. I know that my constant terms in my factorization have to be of opposite signs for my product to be negative. I get, what, 4x squared plus 4x minus 5x. That'd be minus 1x minus 5. Okay. What if I did the 4x with the 1 and the x with the 5? How about, I don't know, positive and negative there? How about the 4x with -1 and the x with the positive 5? See, what the X method does is it tries all of these combinations for you without writing them all out and having to calculate the first term and the last term, because we're pretty confident we know what numbers will multiply together to give us the first term and the last term. It's the interior term that we're looking for. And what I'm doing here is I'm trying, let's see if I do 4 times 5 and 1 times 1, if I could get some sort of target. Like, let's pretend my target was to get -19 here. I'd have minus 20x plus 1x, and I would get 4x squared minus 19x minus 5. Okay. Here I would have 20x minus 1x, 4x squared plus 19x minus 5. The other option I haven't considered, this was just 4 times 1 with the 5 times 1. 5 is prime, so there's only two factors, 5 and 1. But 4 is composite. I can write 4 as a multiplication of two integers in two different ways, in more than one way, let's say. I could have a 2x and a 2x. Now we're not going to have as many orders to worry about here, because if I put the 2x with the 1 and the 2x with the 5, that's not going to be any different than if I put this 2x with a 5 and that 2x with a 1. We really just need to consider the different signs that might occur here. 2x minus 1, 2x plus 5. These are all of the possible combinations, but I'll see them faster if I don't worry about all of these coefficients when I use my x method. Right? This would give me 4x squared minus 10x plus 2x. What's that? Minus 8x minus 5. This would give me 4x squared, of course, minus 5, of course, 10x minus 2x plus 8x minus 5. So possible values of k here are plus or minus 1, 19, or 8. I don't need to put them into order. Okay. You don't want to do this in a factoring question, but trying it out, and these options, these are relatively small numbers or relatively prime numbers as well, which makes this list smaller. The biggest advantage to the X method is that it makes your numbers smaller before they get larger, and you can organize all of this without writing out all of these letters. Let's try it out with at least one example. I think one should do it. Let us write in factored form. And let's try 18x squared minus 76x plus 16. Right. We want to work on efficiency, on doing this relatively quickly. We also want to work on doing this by hand. If you're stopping to pick up a calculator to figure out all of the numbers that you can divide out of 16, you're going to be working slower. I know it might take you a little bit of time to practice by hand, but practicing is the only way you're going to get faster as well. First thing that you should do always, and please do this because it makes my job a lot easier as well, is to check for common factors first. Try to use your simplest type of factoring first. And there is a common factor here of 2. Whether I use decomposition or California or X method, any strategy that I can use to make my numbers smaller will reduce the number of factors that I have to deal with and will make everyone's job easier. Let's see. I know 76 is a factor of, or is a multiple of 2 because it's even. Half of 70 is 35. Half of 6 is 3. 35 and 3 is 38. Half of 16 is 8. There you go. Right. The decomposition method multiplies 9 by 8 and gets 72, and then you're listing the factors of 72. There are a lot of factors of 72, but a factor tree could simplify that for you. Instead, why don't we just consider separately the factors of 9 and the factors of 8? There's not a lot of those. I can make my numbers smaller first. To consider all options, I will need to reverse at least one side. If I reverse this side, I'm writing 2 more columns. If I reverse this side, I'm only writing 1 more column. And I'm going to multiply columns at a time, diagonally, looking for a target sum of -38. I'll consider my signs. I'm pretty sure both my numbers need to be negative here, but I'll check out all options. I like starting on the inside. It tends to give me the answer faster. I don't think that's the case in this question, but that's me using hindsight. So I do 3 times 2, that's 6. 3 times 4, that's 12. With 12 and 6, I could get 18 or 6 or negative 18 or negative 6, never negative 38. So this is not the combination that I want. I don't want a 3x with a 4 and a 3x with a 2. I don't even need to try their signs. Okay. Let's try, I like trying the next row of 3's here. So I'll do 3 times 1 is 3. 3 times 8 is 24. With 24 and 3, I can get 21 or 27 or negative 21 or negative 27, never negative 38. I've tried all of the options for the 3's. So that means I need to try a different column, and I'm just tidying up. If I was doing this in pencil, I'd be erasing that and having more room for more trials. Let's see, 9 times 2 is 18, 1 times 4 is 4, 18 and 4, I could get 22 or negative 22, 14 or negative 14, never negative 38. So that's not going to work. 9 times 1 is 9. 1 times 8 is 8. 8 and 9, I could get 17 or negative 17 or 1 or negative 1, never negative 38. I might be getting a little bit nervous here, but I mean, some expressions will not factor. And what I like about an X method is that it's organized and it shows me when I have tried all of my options. If I try this last column and I can't find two numbers that multiply together to give me negative 38, it might mean that this trinomial can't factor with integer coefficients. What I would then do is something I should have done sooner and double check that I've written down the question properly and that I have removed the common factor properly as well. But I haven't tried this last column yet. Let's see. 1 times 2 is 2. 9 times 4 is 36. With 36 and 2, I could get 38 if I added them together, or 34 if I subtracted them, or negative 34 if it was negative 2 plus 34, other way around. I can get negative 38 if I have negative 2 and negative 36. To get negative 2 and negative 36 from this multiplication, I would need this to be negative 2 and this to be negative 4. So I have found the combination that will work. Let's make sure we don't lose that 2. We haven't divided by it. We've removed a factor. I'm going to put a coefficient of 1 in front of an x in a bracket with a coefficient of negative 4, a constant term of negative 4, and then a coefficient of 9 in front of an x term inside a bracket with a coefficient of negative 2, or a constant of negative 2. So what I've done is I've treated it kind of like the k value. I know all of the different possibilities that would give me factorable expressions. But since I know my value of k here, all I need to do is find the combination that will give me that interior term. And doing this by making your numbers smaller first is always better. The other thing about factoring questions is you don't really need to see a solution manual or even an answer. You don't need to check your answers in the back because you can always check your answer on the spot. Okay, there's not really, I know accidents happen, mistakes happen, but there's not really any reason to have a mistake that you don't catch in a factoring question because you can always check with distribution. 9x squared minus 2x minus 36x, that's negative 38x plus 8. Looks good. And there's my expression in factored form. Okay. Let's try one more. Let's do here, I'll call this part 1. Let's call this part 2. Let's do 24x squared plus 2x minus 15. I do, of course, check for common factors first. In this case, there's no common. Well, here, let's make it a little bit different. Let's make it negative 24x squared minus 2x plus 15. I don't like factoring with negatives. It's not a good idea, and it's generally considered improper. I consider it improper to have a leading negative inside a bracket. So let's start by removing that factor of negative 1, leaving me with positive 24x squared plus 2x minus 15, just the opposite of the question that I gave you. Okay. 24 times 15 is a large number. I don't even know what it is off the top of my head without picking up my calculator. Let me use a method that doesn't require me to pick up my calculator. I know what the factors of 24 are. I can have 24 times 1. It's an even number, so 2 times 12. 2 plus 4 is divisible by 3. That means that this number is divisible by 3. 8 times there. 12 is still even, so if I remove a factor of 4, I could just have that 12. 4 times 6, and they tend to meet in the middle and tell you when you listed all of your factors. 15 is a little bit easier. It's almost prime. 15 times 1 and 5 times 3. Need to consider a reversal. I'm going to squeeze in the 3 times 5 here and the 1 times 15. So this is a mouthful because there's 4 options here and 4 options here, which means that there are 16 options that we need to try. But by keeping your larger numbers on the outside, like I really don't think that 24 times 15 and 1 times 1 will get me a sum or a difference of 2. So I'll leave that and check that last kind of thing. I think it's more likely that my coefficients will happen somewhere on the inside. Okay, and let's multiply diagonally and look for our target of 2. 6 times 5 is 30, 4 times 3 is 12, 30 and 12 aren't different by 2. Pretty sure I'm looking for a difference because of this negative here, but 6 times 3 is 18, 4 times 5 is 20. Got it. Doesn't take too long if we're organized. I mean, sometimes you just get lucky too. Let's see, I want positive 20 minus 18. I always check and make sure that my signs will work out as well. Means I would want positive 5 and negative 3. So let's write this, and I'm fine with this work showing up again in the middle of your question. Just make sure you continue with an equal sign here. I'm going to downgrade these square brackets to curved brackets. A 6x in a bracket with a plus 5, and a 4x in a bracket with a minus 3. I check with distribution. 24x squared, with expansion, sorry. Minus 18x plus 20x, that's positive 2x. I was looking up here for a second, and that's why I paused. No, that's what I want right there, the positive 2x. Negative 18x plus 20x, yeah, sounds good. And 5 times negative 3 is negative 15. So there's my expression in factored form. Okay. It really is the most flexible method for going forward in advanced functions as well. So make sure you practice that.